All right. So today we're still working in 1.3.3. So what I want you to do,
I bet your room's gonna be ice cold next week.
oh yeah, yeah. Well,
It's
hopefully,
starting cold now in here. Can you imagine next week?
yeah. Well, hopefully I'm not here.
Hopefully
Hopefully,
you're not
well,
here.
hopefully we're not here.
Yeah, I heard that.
All right, we're still working in activity 1.3.3, and so what I want you to do. Well, first of all, let's go over what the goal is today, or what we want to do today. So what I'm gonna slide the curriculum over to this screen, and bear with me, my computer is running fairly slow. Okay, I'm gonna have to restart it. Okay, here we go. So here's the curriculum. Let's go back up and revisit those objectives of what we're trying to accomplish. So you guys hear me say all the time, talking about Stephen Covey. He's the author of a book called The Seven Habits of Highly Effective People. And I believe one of his children have written a book called Habits of Highly Effective Teens as well. But anyway, uh, the first habit is begin with the end in mind, and that's what we're doing. So as we progress through this, always remember what the end goal is, what we're trying to accomplish. And so, goal number one is to create a computer model to represent a conceptual idea and inform design decisions. So, um, we have a process, the design process. And generally, what you do, you have that idea, or you sketch the idea, and you write notes on that idea. And once you have a good idea of how you want that product to work, then you're going to model the idea. That's why we're teaching you a CAD program called Onshape. And again, a perfect world would be teaching Fusion 360, but right now we don't have the resources to do that, so that's why we're using Onshape. But Onshape will still give you guys an overall concept of the process in creating uh, products and modeling those products and then creating a prototype of that product. All right. The second objective is we want to create and constrain a 3D model to represent the physical characteristics of a design idea or a physical object. And we've also have learned, and yesterday we placed more focus on it, we understand that a constraint is a limitation or restriction. So let me scroll down if my computer will allow me to. Here we go. All right, in Google Classroom, you're going to have two assignments, or two different assignments. So make sure you pay attention to the ones that are dated 117. There's two separate ones. Now, the first thing I want you to do is you're going to open the first one, and it says, with a partner, perform additional research as necessary to respond to the following. And open that Google Doc, and I want you to answer these questions. Explain the difference between parallel and collinear. And again, you can use the internet to research what the difference is. And I want you to, when you answer those, I want you to answer in complete sentences. Okay, I don't want you to give me one or two words. You need to show me that you absolutely understand the difference between the two. Okay, and what I want you to do is I want you to take those terms and I want you to put it in your own words. I don't want you just regurgitating or copying and pasting what you see on the internet. Okay, and B, answer B, explain the difference between two circles that are tangent and two circles that are concentric. Now, you can look that up, but if you did yesterday's assignment and followed the video, you already know the difference between tangent and concentric. And again, I want you to put that in your own words. And C, can the tangent constraint be applied between a line and an arc? You can do one of two things. You probably should already know the answer to that, but you can open on shape and you can create an arc and just see if you can put a tangent constraint on it. Create a line and, get your arc to attach to that line, tangent constraint. And then what does the coincident constraint do and how do you use it? And again, that could be researched on the internet, but a better way to do it, and this will help you to internalize it, is again, in Onshape, do a coincident constraint. Okay? All right. Now, for the second one here, uh, we're going to create this sketch in Onshape, and we're going to do it together. Okay? And so we're going to create a concave polygon in CAD. And let's define a concave polygon. By the way, this is a concave polygon. So a concave polygon, basically it caves in at some point. It's a polygon that caves in at some point on the polygon. But the formal definition, let's look it up. A polygon that has one or more interior angles greater than 180 degrees. So this would be our interior angle. So here's an obtuse angle. And we know any angle that's greater than 180 is an obtuse angle. So that's the definition of a concave polygon, okay? So let me move this over to the left here, and I'm going to use this picture to create a concave. I'm going to try to create this as closely as I can. And it doesn't have to be perfect. So I'm going to come over here to Onshape, and I'm going to click Create. And I'm going to try to get through this without having to restart my computer because it is running slow. So hopefully it cooperates. And let's just call it activity 1.3.3. And let's say INSTR for instruction 3. And we're going to place that inside our activity 1.3.3 folder. And I'm going to click Create. And what we're going to do is we're going to use the line tool to create it, okay? So the first thing I want to do is I want to create a sketch, and I'm going to choose the front plane. I'm going to come over here to my little cube here, and I'm going to choose front. I'm now going to activate my line tool. Now I'm looking at my picture on a different screen, and I'm going to, don't worry about the origin or creating it around the origin. You can pretty much create it anywhere, but I'm going to start mine up here. Basically just like they do it on the picture. And you can see how slow my computer is working. And I'm just going to create another line where that point is, I'm not sure if I even constrained that point or not. All right. And this is going to be an acute angle here. And here's my obtuse angle. Okay, I don't like the way mine looks, so I'm going to make a few changes. So I'm going to press Escape to deactivate my line tool. And I'm actually going to move this over a little bit. And by the way, the answer to that coincidence, notice every time I move a point over, that coincidence symbol appears. Okay, I think that looks a little bit closer to the picture. And this one. So this angle is acute. This is an acute angle. This is an obtuse angle, greater than 180, greater than 180, and greater than 180. So one or more, a polygon is basically a geometric figure that has one or more interior angles greater than 180 degrees. And of course, this has several. All right, let me fix this. So now I'm going to go back and look at the curriculum. And this tells me, I'm looking at instruction 4, and it tells me select each line in your sketch one at a time and drag it with your mouse. And then describe the behavior in general when a random line is dragged. Now, I'm not going to have you guys write anything down, but I want you to make mental notes on what happened. So what I want you to do is I want you to choose the various lines and just drag it around, see what happens. And by the way, let me connect this one. Notice that, by the way, this is a teachable moment. If you ever have a situation like I just did, where this line isn't connected, you see what's happening here? All you have to do is just take that point, and then it connects. Just bring it down to the various points. So I'm gonna click here. I'll let it catch up here. So you see what I'm doing here? Okay, so this can, so you could drag it and change the shape however you want. So after you've done that, after you dragged every line, I want you to undo everything. Remember, you can do a Control Z, or you can click this button to undo everything that you did. So I'm going to do a Control Z several times. But I do want that to be connected. So what I'm going to do is take this point and connect it. Okay, now it's connected. It won't let me go below this line. So it's restricted beyond this line. Okay, so I want to, so this is the way, this is what I'm going with. And it says to go ahead and accept the sketch or finish the sketch. So I'm going to click the green button to finish the sketch. And then it says extrude the shape. So you can choose how much you want to extrude it. Okay, so what I'm going to do, let me undo something. So I'm thinking the reason mine didn't extrude is because it's not connected somewhere. So I'm going to cancel that. But if yours worked out, you're good. Let me see what happens here. There we go. Okay. And you can choose whatever extrusion you want. I'm just going to choose 2 inches. And what I want you to do, let's go ahead and change that instruction. Let's make that instruction 3-8 because that's taking us from instruction 3 all the way to instruction 8. Okay, so what I want you to do is go ahead and create a multi-view drawing. So I'm taking my mouse here. I'm going to right-click part 1. And as soon as it catches up, I'm going to create a drawing. I'm going to choose this one, the ANSI A. Remember, if it doesn't show up, you can click down here and show more drawing templates. Okay, so by default, it gives me my front view. So I'm going to place my front view here. And then I want my side view here. I'm going to come up here and click Insert View. And I'm going to choose my top view. And of course, the upper right-hand corner is where I want my isometric view. Okay, something went wrong. Let me change that. We delete that. Let's do this again. Let's go isometric. There we go. We're going to come down here where I'm going to double click. And I'm going to delete all of that, and I'm going to type activity 1.3.3 INSTR 3-8. I'm going to accept it. And I want you to take a screenshot, and I want you to upload it for a grade.